Hi everyone, I'll discuss about embedded machine learning. What is embedded machine learning? Embedded machine learning refers to deployment of machine learning models on embedded systems. Basically, in the regular PC embedded models, right? You'll deploy it on a cloud server or a regular high-end servers to for the computing to occur. So in this case is what you have devices where the machine learning models, right, are embedded into the small devices. So where you can use this small devices, the regular usage of cloud servers, right, will be minimized. So you can use this embedded products, right, anywhere in the world. So all the machine learning concepts, right, models, right, will be executed itself. So basically, computing systems that perform dedicated functions within larger systems. Basically, you'll have some functions, right, where that execution will be done as part of your large your software, which is embedded into your product. Embedded machine learning enables devices to process data and make decision locally. Basically, right, in some cases, you want some decision, right, to be taken. Like, for example, suppose there is a crash in the device, right? So you want the some operation, right, to shut down the device or to log some data, right, to the particular file and shut down. So that kind of processes, right, can be executed in embedded machine learning. So these are the key components. First one is the model training. So in this case, what happens is the typically the model what you are executing, right, will be optimized and the base model, right, will be executed in the cloud servers using some data sets. So there you will have the model training. Then you will deploy these models, right, to the target hardware. There you will do the model optimization. So once you have optimized according to your target area, you need to deploy it, the model deployment. The more optimized model is deployed to the device where it can perform some execution. Okay. So all the issues while deployment are executed as part of in a runtime. So this is some of the applications, IoT devices where you can do this edge computing, because embedded machine learning is also called edge computing, where all these machine learning modules, right, is be embedded to these devices. The examples are smart homes, industrial IoT, smart agriculture in case of IoT devices. Wearables, you have health monitoring systems, right, and fitness tracking. Like in case of health monitoring, right, suppose if there is any a problem in the patient's health condition, right, you need to log some of the logs, right. So that kind of artificial, right, because you need not log all the times, right, only at that instance, right, when there is an issue with the patient, that will be logged and some actions can be logged. So that kind of health monitoring will be applicable in case of embedded learning. You have this automotive field where you have this advanced driver assistance systems, SADAS, and predictive maintenance. These are some of the things, right, where we can use. So in case of robotics, right, you have this object data recognition and autonomous navigation. And consumer electronics, you have smart cameras and voice assistants. In case of smart cameras, right, like for example, if you want if there is an unusual activity, right, going on in front of your house, right, you want a instant call, right, or instant SMS to be delivered to either you or some other key people, right, that you can do it when you have some uh, models embedded into the camera, smart cameras. So techniques for optimization. So these are some of the techniques. Model quantization, so where you will reduce the from 32-bit floating numbers, right, you'll reduce it to 8-bit numbers, 8-bit integers, so that, right, you can reduce the precision and weight and activations. Pruning, so wherever you are feel that you can remove some of the neurons and connections from the model, you can do that. And knowledge distillation, so you are training a small model, right, to replicate as a behavior of a larger model. Thus you are doing a optimization here, and you are enhancing the qualities of a smaller student model. And you'll use the edge AI frameworks. Some of the frameworks are Flowlight, PyTorch Mobile, and ONXS Run 20 Run Embedded. And the challenges in embedded machine learning. So here you have this resource constraints where the devices, right, are have some limitation of the power and memory, right, so you need to optimize according to the power and memory constraints. So latency requirement, so if you need to be real time processing needs will be there, so latency should be reduced here. Model size and complexity, so balanced model performance and resource usage. So there will be complex models here because you are optimizing, and you're doing a lot of activity, right, in the your embedded device itself. And deployment and maintenance, in these cases deploying the model will be compulsory in every device, right, and perform and enhancing the performance of the device is also challenging here. So some of the tools and frameworks, right, we can use in embedded, TensorFlow Lite for the mobiles and embedded devices, and for microcontrollers you have TensorFlow Lite as well as for microcontrollers as well. A mu tensor for edge devices, ARM based, there is one more the, framework, uh, and edge impulse, right, there is one more framework which normally, right, you can use for NRF machine learning models, NRF boards. So these are some of the tools and frameworks which you can use, right, to develop embedded machine learning models. So have some practical examples which will come up in the next video, and you can see these subscriptions, right, in the comment section. Thank you.